Welcome everyone. In this video lecture, we will solve a MOSFET based problem. So the problem is find the approximate value of ID and VD. We have to find the value of the drain current ID and the voltage across the drain in. This one is the drain in, and the circuit is operating in the linear region. It is given the transistor operating in the linear region, and the given things are threshold voltage and K and dash W by L. So this one is operating in the linear region. So we have to find ID and VD. So basically this one is our gate in. So better to write gate in, drain in, and source in. So here what we can do, first thing, the circuit is in the linear region. So we have to write the drain current equation in the linear region. So drain current equation in the linear region can be written as K and dash W by L VGS minus VT VDS minus VDS whole square by 2. So this one is the drain current equation in the linear region. So K and dash W by L is 1 milliampere. So 1 milliampere per volt square. So just I am writing 1 milliampere, or better to write 1 into 10 to power minus 3 K and dash W by L. VGS value is simply our 5 volt. Here VGS is VG minus VS. VS is grounded. This VS is grounded. VS is 0 volt. And this VG is connected to this 5 volt. Okay. So simply this one is 5 minus 0. So this value will be 5 volt. So the VGS value will be 5 volt. So simply we can write 5 minus VT. The salt voltage is given 1 volt. So I am writing 1 volt. Okay. And VDS, the other parameter is our VDS. So VDS can be written as VD minus VS, and VS is already 0. So this can be simply, we have to write it. VDS is simply our VD. Okay, VGS is 5 volt and VDS is simply our VD. So I am writing this as a VD minus VD square by 2. And if we solve this one can also write 1 into 10 to the power minus 3 divided by 2, then 4. So it should be 8 VD minus VD square. I am writing this as a equation number 1. So this one is a drain current. Okay, so now one more equation we can write by just taking this value, by taking this structure. Okay, I am writing here by just, okay, this value is VDD, that is our 5 volt, and this VD is our unknown, so make it unknown. Okay, and this will be our ID, and this value is 25 kilo ohm. So this ID we have to find. So this ID expression is nothing but simply the drain current, okay, is VDD minus VD divided by the RD term. RD, generalized expression I am writing first. So VDD is 5 minus VD by 25 kilo ohm. Okay, or one can also write this as a 5 minus VD by 25 into 10 to the power minus 3. So say this one is our equation number 2. Okay, so this ID in linear and this one is also same. This ID is same as that of this ID. So by equating 1 and 2, what I am writing here, by equating 1, by equating 1 and 2. Okay, so what we can do, equation 1, that is our 10 to the power minus 3 by 2, 8 VD minus VD square equals to 5 minus VD by 25 into 10 to the power minus 3. Okay, so this should be cancel out. Okay, So next, what we have to solve this one. So one can write this as a 8 VD minus VD square into 25. I am just multiplying here. Then 5 minus VD into 2. So there will be a quadratic equation. So just multiply 25 into 8, 200 VD minus 25 VD square equals to 10 minus 2 VD. Okay. So one can simply write, if you put this as in the right hand side, or simply we can write this as a 25 VD square. Okay. Then minus 202 VD. Okay. Plus 10 equals to 0. So this one is our quadratic equation in VD. So we can find the value of VD because we have to find the VD. So this one is simple. We can do like this. VD will be minus B. So this one is B. So better to write plus of minus B square. So minus 202 whole square minus 4. A is 25. So 20 into C into 10. Okay, this one is multiplication. Okay, by 2, a simple quadratic equation concept, 2 into 25, or better to write multiply. Okay, then after we can solve like this. 202 plus or minus 202 whole square. So if we do the calculation, it will come 40804. Okay, minus 2400. Okay, so this will be the n in denominator 50, or one can also write this as a 202 plus or minus a square root of, if we solve this one, if we subtract 1000 from this 40804, it will come 39804. You can do in your calculator by 50. So now next, so if we solve, it will come plus or minus, if the square root of this 39804, it will nearly come 199.50 divided by 50. Okay, so now there is a two roots, so one can write this as a VD1. Okay, one root like 202 plus 199.50 by, oh sorry, 50 by 50. Okay, so this will be around 401.5 by 50, so it value will be around 8.07. Okay, one VD1 means the one root will be this, and the another root will be 202 minus 199.5 divided by 50. So it should be around, if we subtract, then it should be 2.5 by 50. So 2.5 by 50, it will come 0.05. This one is volt, this one is the volt. Okay, but now we have to decide which one is the correct one. So this will be the not correct one, VD1. Okay, because this one is 8 volt, this one is our 5 volt, and we are getting 8.07 volt, so it cannot be possible. Okay, so the lower value will be considered for the linear operation. So VD2 value will be our 0.05 volt. Okay, now we have to find the value of ID. So now we can select any equation 1 and 2. So now I am selecting equation 2. From equation 2 we can find the value of ID from equation 2. Okay, once again, from equation 2, what is equation 2? For this one, for this one we have written, this one is our equation 2. Okay, id value equals to 5 minus, okay, or once again I am redoing the circuit here. This one is VDD, that is our 5 volt. VD is now known to us, 0.05 volt. ID value we have to find. Okay, and RD value is given 25 kilo ohm. So we have to find this ID. We can also use the ID equation, then get the equation in linear region. That is our equation one. So, but this one will be very easy. So ID value will be VDD simple network concept by RD. So this should be 5 minus 0.05 by 25 kilo ohm. So if we solve this one is 4.95 by 25 kilo is there. So if we make it up, it should be minus 3, 10 to the power 3, then the minus 3, then 4.95 divided by 25 is nearly 0.198. This one is milli, so 10 to the power, so it is nearly 0.2 milliampere. So the ID value, simply we can say it approximately 0.2 milliampere. So like that we can solve this problem. So the our ID value is 0.2 milliamperes we have find through this one, and VD2 value is 0.05 volt. So the thing is that we have to use both equation, equation 1 and 2, for solving the value of VD. So the linear, so we have to write the linear expression, this one, okay. And this current is same as that of this, okay, by just using this circuit, okay. So we have to find VGS, and VDS is VD because source voltage is 0. So like that we can solve this simple problem. So the final answer for this question will be, okay, VD value, VD value, okay, VD value will be around 0.05 volt, and ID value will be 0.2 milliampere. So this is all about this question. This question is an example from the microelectronic circuits book. So thank you for watching this video.